Assalamualaikum. Hi, my name is Muhammad Izwan Syahmi bin Muhammad Syamsuri, number matrix CN190111, and my supervisor is Technologist Dr. Nasrufiq bin Cekpa. So my project title is Potential of Bamboo Leaves as Natural Coagulant in Municipal Wastewater Treatment. For chapter 1, I will cover about project background, problem statement, project objectives, project scope and significance of the study. For project background, coagulation which eliminate colloidal pollutants as primary purpose in wastewater treatment. Coagulants are chemical substances which introduced to the water to remove the forces that stabilize the colloidal, thus allowing the particles to float. Aluminium and iron coagulant being generally utilized in most areas. The drawback of aluminium and iron type coagulant includes potential of intestinal constipation, memory loss, seizure, fatigue, and learning problems. Natural coagulants have recently been given a lot of attention in wastewater treatment. Natural coagulants are produced by animals, microbes, and plants. Natural coagulants like Dorylicus deblab, Azathiotum indica, and Moringa oleifera are discovered to be high in proteins that are soluble in water, as well as contain an overall positive charge while in solution. Bamboo leaves had a high percent of protein on average. Bamboo leaves also comprise relatively high concentration of the macro mineral. This similarity of properties and characteristics between the natural coagulants and bamboo leaves have which make it a potential to become a natural coagulant for wastewater treatment. For problem statement, aluminium and iron coagulants are commonly used in most industries. Nevertheless, when these two elements are used as coagulants in wastewater treatment, they may cause several dire consequences on human health. This results in recent emerging researches on developing and utilizing natural coagulant in treating wastewater in recent years. Bamboo leaves are explored on its potential as a natural coagulant for water treatment. Natural coagulant chosen for this research was adsorbent derived from the leaves of bamboo tree. Previous studies used other plant-based coagulants such as algae, Tamarisk indica seeds, and Moringa oleifera seeds were among the most effective primary coagulants for water treatment. Benefits of this plant-based over the conventional treatments are that it is biological and edible. The objectives of this project are: the first one, to study the bamboo powder sample characteristic using XRD, FTIR, and SEM. The second one is to study the effectiveness of adsorbent derived from bamboo leaves as a potential wastewater treatment agent. And the last one is to compare the effectiveness of adsorbent derived from bamboo leaves with commercial coagulant. The project scopes of this study is: the first one, the adsorbent was prepared in the form of powder. There were three samples altogether where different sizes powder of 150, 200 and 250 micromilliliter respectively. The samples undergo turbidity tests using turbidity meter to determine is the most effective for municipal water treatment. Hence, all the samples were characterized using XRD, FTIR, and SHM. The second one, the jar test experiment will be carried out to investigate the coagulability of bamboo leaves under varying doses 50, 70, and 100 mg per liter, and initial turbidity 90, 170, and 300. The test water is kaolin wastewater. The significance of the study: the use of environmentally friendly coagulant in the coagulation and flocculation procedure might enhance effluent treatment. Natural coagulants have been shown to reduce turbidity in water towards acceptable levels in the previous studies and can be single-use or in combination with alum. Second, bamboo leaves could possess an exciting alternative to replace potentially harmful synthetic coagulants to reduce the turbidity of the water and make it more suitable and safer to be consumed by humans. Next, I will discuss about the chapter 2 of this study, which is a literature review. Bamboo leaves property. Bamboo leaves possess a high concentration of active polysaccharides in addition to bioactive components such as flavonoids, glycosides, and polyphenols. Polysaccharides as well as flavonoids are main bioactive constituent in EBL, which is bamboo leaf extract, with bamboo oligosaccharides playing an essential role. Table below shows the average bamboo leaf mineral composition. It implies that bamboo leaves comprise a well-balanced amino acid content and high protein. The application of bamboo leaves. Due to technological advancement, bamboo leaves have become widely employed in domestic products and be extended to industrial uses, for instance, production of food and feedstock and pharmaceutical industry. For pharmaceutical industries, bamboo leaves have been used as a treatment in earlier civilization to cure fever, hypertension, diarrhea, even excessive thirst. Bamboo leaf extracts were shown to offer essential pharmacological and therapeutic qualities such as antioxidant, antimicrobial, as well as anti-inflammatory capabilities. For food industry, bamboo leaves been officially acknowledged for natural antioxidants in China, and therefore can be utilized as a new flavoring agent in edible oils, seafood, as well as processed meats. The wastewater treatment process. Municipal wastewater is the common type of wastewater in the low-strength waste circulation classification. It has the ability of transforming the chemically energy output in raw municipal wastewater organic contaminants to safe drinking water. The significance of wastewater treatment are to eliminate harmful bacteria from influent wastewater, making it safe for human consumption from hepatitis and cholera, as well as to protect the environmental degradation from toxicity. There are three treatment levels of wastewater, which are primary, secondary, and tertiary, which shown in the diagram below. Coagulation and flocculation. The primary physiochemical treatment method employed in treating wastewater to minimize colloidal cloudiness as well as suspended particles. Previous research has shown that the coagulation process can eliminate 40% of organic compounds, including nitrogen, from wastewater. Coagulant dose, settling period, and pH are the major elements impacting removal efficiency in wastewater. In general, the coagulation and flocculation process involve four steps, which are charge neutralization, sweep coagulation, bridging, as well as patch flocculation. Natural coagulant. Microbial polysaccharide, starch, Moringa oleifera, and chitosan are examples of natural coagulant utilized in wastewater treatment. Coagulants with natural properties are said to be safe for humans. Natural coagulants are derived from other natural sources that contain a functional group. Agricultural waste, for example, has a good coagulation characteristic owing to the presence of carboxyl as well as cyanol groups. Using natural coagulant improves nature as well as ecology by using biodegradable components. Isothermal absorption model. Isotherm describes the connection between the equilibrium adsorbate concentrations in the liquid phase and the equilibrium adsorption quantity on the solid phase. The model may be used to construct equilibrium adsorption data and explore adsorption parameters including adsorption processes, maximum adsorption capacity, and the adsorbent characteristic using isotherms. Below shows the classification of isotherm. Langmuir adsorption model is a straightforward model of adsorption equilibrium that works both at high and low pressures. It describes the area occupied by the adsorbed molecules on the surface of solid adsorbents, like a function of partial pressure or concentration at a constant temperature. For this absorption model, there are a few assumptions that can be made. First, molecules are absorbed on the surface at distinct active sites. Second, each active site can be only absorbed by a single molecule. The third, the absorbing surface is homogeneous in general. The fourth, there is no contact between the molecules that have been absorbed. Freundlich absorption model. It describes an empirical relationship between the quantity of gas absorbed into a solid surface and the gas pressure. The similar relationship exists between the concentration of solid absorption on the surface of a solid as well as the concentration of the solid within liquid phase. The Freundlich isotherm was used to model multi-layer absorption and heterogeneous surface in numerous published publications. Langmuir and Freundlich isothermal application. These isothermal models have been extensively employed in most absorption investigation to analyze absorption processes. Langmuir adsorption is considered being a monolayer process. The maximum adsorption capacity each unit absorbable mass is computed that quantifies the absorbent solutes affinities. For foundation type absorbent is a multi-layer technique that gradually increases the amount of absorbed solute with unit absorbent mass. The removal efficiency or necessary absorbent mass was effectively predicted utilizing given sets of beginning circumstances by integrating Langmuir and Fendley isotherms with mass balance of solids between liquid solution and solid absorbent phases. This allows for the estimate of the absorbent mass necessary for target percentage removal be beneficial in pollution elimination absorbent processes. Design of experiment. The experiment is conducted to evaluate the interaction of three variables, which are the size of bamboo leaf powder, coagulant dose, and turbidity, in finding the best parameter for bamboo leaves to become the natural coagulant. This is a design that made up of three factors, which has the three levels. So I'm using 3 power of 3 full factorial designs since 3 variables present in the study. Therefore, there are 27 total experiments that need to be employed for this design. For Chapter 3, I will discuss about the methodology. The first step is the preparation of bamboo leaf powder. First, the leaves will be sun-dried for 24 hours. The leaf will further oven dry in the oven for 90 degrees Celsius for 24 hours. The leaf then be grinded and sieved into size of 150, 200 and 250 micromilliliter respectively. The second step is the preparation of kaolin wastewater. In 1 liter of distilled water, 10 gram of dry kaolin being distributed. Then mix and stir using magnetic stirrer for 1 hour. The prepared kaolin wastewater suspension will allow to settle for 24 hours to allow complete hydration of the kaolin. Then we can proceed to the jar test operation. In the jar test operation, 6 beakers together with 6 spindle steel paddles added with 200 ml of synthetic kaolin wastewater. Then in the beakers, different concentration of coagulant were introduced. The beaker were shaken for 1 until 3 minutes at different mixing time and speeds, which is around 200 to 250 rpm, as well as 12 to 15 minutes at slower mixing, about 30 to 40 rpm. Then, the suspended were left to settle for 20 to 60 minutes after the agitation was ceased. After 1 hour, the middle supernatant from each beaker were collected with pipette. After the jar test experiment complete, now we can analyze using turbidity meter, X-ray diffraction, Fourier transform infrared, and scanning electronic microscope. Materials and apparatus. In this table, it shows the materials and apparatus that can be used for this experiment. Chapter 4, Expected Result. The expected result of this study is that the powder bamboo leaves has the potential to be used as a natural coagulant in wastewater treatment. Previous research shown that sample has the complex pore structure, large surface area as well as different oxygen-containing functional groups on its surface essential for absorption characteristic. It is expected that the bamboo leaf powder could compete as a natural coagulant with other commercial coagulants such as alum, ferric sulfate, and ferric chloride. Chapter 5, Conclusion. The research generally focused on identifying the effectiveness of absorbent derived from bamboo leaves in determining the potential of powder bamboo leaf as a natural coagulant in wastewater treatment. The high protein and amino acid composition as well as polysaccharide comprised within the bamboo leaves make it can be produced as coagulant due to its similarity to other natural coagulants in terms of composition. Furthermore, with the isotherm models such as Langmuir and Freundlich models in evaluating the efficiency removal can assist to estimate the mass required for absorbent be used for pollutant removal. So that the ends of my project title presentation. So thank you.